thank you to Venture Southland for the opportunity to come along today to speak to you all. As Jerry mentioned, there'll be the three of us presenting. I'm with Energy for Industry. That's the brand, if you like, of Pioneer Generation. We're all part of Pioneer Generation. We are an integrated energy company based out of Central Otago, in Alexandra, owned by Central Lakes District Trust. And we have assets from here in Southland and customers here in Southland right through to Auckland. So I want to talk a little bit about our business and what we're about. Murray then is going to talk about Wood Energy New Zealand, our wood energy business. Put your hand up, please, Murray. Thank you. A lot of you will know Murray from WENZ, and he'll talk about the supply chain that we've put together to support some of our industrial scale sites in wood energy and other customers as well in the region. And then Tony is based in Dunedin, looks after our Otago and Southland thermal assets, and he's going to talk specifically about our conversion of Boiler 1 at Dunedin from coal to wood chip. Right, so just a little bit more about our Southland assets. We have a partnership with Southern DHB. One of our assets is what we call the Energy Centre at Kew Hospital. The Southern DHB, great customer and a great supporter of renewables with us. They've joined with us in this investment of a new dual fuel boiler at the Kew Hospital. So we commissioned that last year. Another asset of ours just underway, the civil works for a wind farm at Flat Hill here in Bluff. So that's just kicking off now. We'll be looking to commission that about middle of next year. It's a $16 million investment, so a sizable investment for us as a business, and I believe for the region as well. And many of you will be familiar with the Monowai Power Station, just the side of Fiordland. It's one of our generating assets in the group. So, as I say, we've already got a reasonable established asset base and team operating here in Southland. Okay, a little bit about the presentation. Firstly, the Dunedin Energy Centre. Well, you know, what is it? We'll talk a little bit about that. A little bit about some wood energy fundamentals and economics, and from our experience, what stacks up, what doesn't. Murray will then talk about the supply chain and the WENZ operation that we've set up to support conversions to wood chip. And then Tony will talk specifically about our experience at Dunedin Energy Centre converting a coal-fired boiler, old technology, into burning wood. So let's get underway. Firstly, what is the Dunedin Energy Centre? Well, as you can see, it's probably the finest piece of 1960s architecture on Castle Street in Dunedin. And it is part of a district energy network. Steam pipes come from the energy centre here under the road, across State Highway 1, supply a number of our customers. The technology inside it, no different. 50s and 60s technology. And we'll talk a little bit about some of the challenges of making that work with wood shortly. It's part of the district energy scheme, as I said, and it's one of two in the country. The second one was one we set up in Washtike and Timaru, supplying again process steam to industrial customers. Our customers in Dunedin, however, you'll be familiar with them all, I'm sure. Cadbury's Confectionery, New Zealand Towel Service, or ALSCO, Southern DHB, and of course the University of Otago. Now we're fortunate to have with us today the energy manager of the University of Otago, Hans Peach. Hans is a believer. Hans is a huge supporter of renewables. Hans couldn't wait for a policy from the Ministry of Education, so he's just got on with it. And I think, when did you put the first wood boiler into the university, Hans? 6, 7 years ago? 7 years ago, yes. Yeah. So a great supporter, and I think, you know, if you've got time at lunchtime to catch up with Hans and talk about his experiences, it'd be well worth doing. Okay, just some simple economics around wood chips and or wood energy, wood as a fuel, from our experience. If we look at this price curve here in the green, capping the top here is the price of export. So typically that's setting the cap price, if you like, in terms of wood, pulp logs on the wharf. Not particularly economic for us and hard to compete against fossil fuels in this space. So hence we're having to move down the price curve to stack these things up. And again, we're having to, I guess, choose the island to compete in. We don't get too many wood opportunities away in the North Island. They've got gas, the gas is relatively cheap. So we're moving down the curve here, billet woods, domestic wood lots, and residues, sawdust. And that's where we're typically getting these opportunities away. We have a partnership with Silver Fern Farms in Balclutha. We've been working with them now 6 years since we invested on that site. It's a plant that runs off sawdust, local residues, and you know, after 6 years on that site, the price of the local coal pretty much still matches the price of the local residues. Pound for pound, there's not much in it. When we got this investment underway, this partnership underway with them, we had a little bit of tailwind in the form of a carbon price. Of course, that's been washed right out now, and as I say, it's at times pretty difficult to compete with the lower grade coals and lignites. We've got a plant in partnership with Christchurch City Council in Christchurch. At that site, we're burning lower grade fuels, low grade wood, billet wood, and some landfill diversion, some clean, untreated landfill wood, which we're chipping up and using as wood. So, as you can get a sense, we're having to move right down the price curve here to stack these up, to give us enough quality, sustainable wood supply. And it's very much a regional story as well. That's certainly our experience. Okay. We've chosen to affiliate ourselves with the CMARS brand. That's the environment, or what was Landcare, and their CMARS brand is certified emissions measurement and reduction program. So we've been part of that affiliation now for 5 years. It's for us a program which I guess suits our business. We're an emitter. You know, we have gas plant, we have coal plant, we have wood and residue fired plants. So this is a program where we target, we benchmark each of our sites and our generation sites and our offices in terms of how much carbon we're using each year. And we set targets each year on how we reduce those. Now, the Dunedin Energy Centre, which we'll talk more about shortly, I guess is our biggest lever in terms of being able to reduce the carbon across our portfolio each year. Because it's ordinarily fired on coal, obviously the more wood we can put in there, the less the carbon. So, without further ado, over to Murray, who will talk a little bit about Wood Energy New Zealand. Thanks.
Hi, just to give you a little bit of perspective, we have about 14 customers in Otago and Canterbury. Predominantly they in Otago. We supply some schools, swimming pools, 4 sites at the university, Otago Polytech, a winery and a swimming pool, so big range. And we're about 116,000 gigajoules a year of wood chip, and of that 37,000 gigajoules goes into the DEC. So it's about 30% of our total volume, and that is usually just over the summer months, which suits us quite well because it helps balance out our supply quite nicely. Now, I just really want to make a few comments as we go through. When we started out with the DEC, there was a number of options in terms of raw material, but we didn't have the option of using sawmill residues, not at the sort of scale we wanted to. But we also knew that we had to produce wood fuel which was lower moisture content, so we couldn't use green chip because it was going to go into coal boilers. So we ended up using, doing billet wood. Their billet was just short logs, sort of anywhere between 1 metre and sort of 3 metres. They come in on a tip truck, and then once they arrive, we stack them and leave them sitting around for a summer, basically, to try and get the moisture content down low enough. There is an issue in terms of billet wood is only recovered from forests when they've got a market. If there's no market, they basically leave it on the skid or they'll push it over the skid. But if you recover it as part of a logging operation, then the logging contractor actually gets paid for it, and so gets paid a proportion of the logging cost. And so automatically it increases the price of the raw material to what it would be if it's left on the skid. But when we set this up, a lot of it was around continuity and security of supply. And so if we hadn't have done that, we would have ended up having to go into forest and try and scrape around on skid sites to be able to find that raw material. We didn't have the equipment to do that either, because you find that if you go into skid sites, you end up with, it just gets pushed to the back, it gets buried with dirt, and you have to go back and recover it later. So hence we did go with the billet wood, but there's quite a cost in terms of raw material cost in that. So it's a chipper and some of the billet wood there, but when doing it the way we do, you need quite a large site because you are stacking big volumes up to sort of 8,000 to 10,000 tonnes on a site, and so you're talking in hectares of land rather than square metres. You're trying to find a site close to a city or close to where your customer is. That's quite an issue. And we're using billet wood trucks. You also have to have a place where the truck's stable enough that the trucks can tip off. If they can't tip off from muddy sites, they'll tip over. So there's quite a bit just in terms of working that out. And obviously you've got to have some storage facility for your chip to keep it clean. Just the logistics side of things. I think I've gone through some of that, but the logistics get quite tricky because often you find that each of the little customers, particularly small customers, have got their own sort of idiosyncrasies in terms of their bins or how they can take delivery. And so from a wood fuel supplier's point of view, you're trying to use the same set of kit to do multiple sites. And sometimes there's compromises in terms of delivery volumes or the logistics to try and make that work. Ideally, everything would be the same, but it doesn't tend to work out like that. I did want to spend a bit of time just on the quality and specification sort of side of things, because there's a set of standards which the Bioenergy Association publish in terms of wood fuel, so which will specify the moisture content, the size of the chip, and the ash content. Now the moisture content is straightforward, but not necessarily that easy to do. The sizing is trickier because it specifies maximum size, it specifies the amount of fines, and your averages. But you'll find that some boilers work better on some chip than others, and just because it meets a specification doesn't mean to say that it'll actually go through a boiler. So you often do have to spend a bit of time fiddling around trying to get something that works for the customer. Luckily, the DEC doesn't fall into that category. It's been a boiler that will handle a wide range of fuel types, and but it does need wood fuel that's sort of under 35%, well, under 40. Tony would like it under 35, probably like it at 30, but it does need, we've managed to do average 35% moisture content chip with our billet wood. We don't supply any of our smaller customers, or very little volume of our smaller customers, out of billet wood because we can't get the moisture content low enough. So for I suppose a Southland initiative, if you're trying to do it out of forest residues, I'd say you're going to have to put an artificial drying. I don't see that you would be able to do it any other way, because you'll struggle. The small boilers like 25%, 20, 25, you can get to 35, you can't get that 10 out any other way without putting it through some sort of drying process. So I think the good thing for us is that the DEC has given us, as a wood fuel supplier, some scale to allow our business to grow and sustain over the summer months. Otherwise, it's a very peaky business. It's based in the winter months, and so by doing the DEC, we managed to keep our business going for 12 months a year. Thank you.
Thanks, Murray. Stephen. So specifically, we'll just be looking at the boiler conversion in Dunedin. So back in 2008-9, we dabbled in a little bit of wood fuel, mainly sawdust, initially just with mixing with coals, just to see where things would go or could go. 2009, we did the initial upgrade of the fuel system. Specifically, that was to move, for us to move into lignite, probably since Mohi was potentially closing down. So we did some upgrades there. Part of those upgrades, the stokers were refurbished, or we actually put new ones in, and at the time we believed that they would be effective for boiling wood chips. So, so we tried that. Setting up the boiler initially from coal to wood chip wasn't a big move. It was just basically combustion tuning that we initially did, and then Murray just started supplying us chip at, as he mentioned, around 30-35% moisture. So some of the issues that we came up with straight away with that was the specific stokers were designed for firing coal on it. We had quite a few issues with the stokers actually jamming with the wood chip. The wood chip didn't give where the coal would basically break down within the chipper, within the flinger on the boiler. So that was sort of a nuisance issue. It created, you know, times each time it went down, the boiler sort of stopped. So yeah, there was issues around, you know, losing a bit of production at the time. But because we were doing it over the summer months, the overall load was a little bit reduced. When we first discussed to go with wood, you know, there was a bit of apprehension from the operators, but at the time we did have several guys on staff who had previously fired wood chipped or solid wood boilers. They sort of led everybody through that issue, so everybody became quite comfortable. So the staff buy-in was pretty good. Because of the wood chip sizing, the jamming of the stokers, the overall output was reduced, so lower than expected wood fuel consumption, and as mentioned, the minor operating issues associated with the wood fuel. It's the one there. So we sort of went for one summer like that, and then because of the issue, you know, it was never intended to go through the winter so we converted back to coal again. So the next summer we installed pneumatic feeders, which are basically referenced to as windswept spouts. So basically the wood just drops into a hopper, and the wind air blows it onto the fire. So that's pneumatic feeders were specifically designed to operate on wood fuel, removed capacity limitations, so we were able to increase the volume of wood going through there. This would enable the DEC to achieve the target wood fuel usage, so that was increased significantly. Actually up, pretty much close to where we wanted to be, what the original plan was. So the installation at this stage we still do change over from summer to winter. So to change from the windswept spouts back to the coal feeders, it's about a 12-hour operation. With a couple of guys, we could probably push it if we really need to 8 hours. So converting one to the other is quite simple. One of the advantages of the size boiler that we had was that it had quite a good furnace, good sized furnace. Wood boilers tend to have larger furnaces, but this it was quite adequate for that. So the outcomes of all this conversion, which is pretty positive for us. It was anticipated that wood feeders would improve the wood fuel and guaranteed minimum performance up to 80% of the boiler rated capacity. So the boilers were able to do 10,000 kilograms steam an hour. So once we changed to the wood chip, we actually had to cut the firing rate, had to pull it back because we were actually over firing. So with the wind spouts, once we got a good fire established, it took off like a rocket pretty much. At that time, Murray was still supplying 28-35% moisture. Over time, we experimented with the moistures, or more by default than anything. We were able at times that we actually moved up to as high as 43% moisture. It wasn't continuous, but a good mix of that. The other outcome was Murray was screening for quite a fine chip to overcome the initial stoker thing, but we moved to a bigger chip, which made Murray's chipping a little bit easier. We found that actually a bigger chip was actually quite a lot better for the fire. Once you got an established fire, it was good. So that boiler now, when we're firing, we use that as a base load, so it chugs along at about 10 tonne an hour or thereabouts. When the moisture goes up a little, it drops off a little bit, but not significantly. So the staff are more happier with this. There's no more jam ups and things like that. The emissions, because the boilers are into a common stack, it was difficult to actually determine what the emissions are. But overall, the Energy Centre has really good emissions. We're pretty much below 1% sort of thing. The cleaning of the fires, as mentioned before, there's less cleaning of it. The guys now only have to probably clean the fires every 5 or 6 shifts. Under wood, you might have to clean it, under coal, you would be cleaning your fire every shift, sometimes twice a shift. So the waste on ash was hugely reduced. So that's generally the overview of where we went with the changes. This time, has anyone got any specific questions that I could sort of...
I'm not sure why you changed from wood to coal during the course of the year.
Well, there's a couple of things around that. Really, because we're using the seasoned wood that Murray spoke about, we need to have that seasoning over the summer, and basically we combination of getting close to running out of supply and the difficulty in the winter time. We have more boilers going. We have to coordinate the deliveries around the coal, and we found it for supply to the customers, reliability, that we convert back to coal. It cuts out all the supply, continuity supply issues for us.
So if you could build up a stockpile of wood, you might counteract that.
Yeah, well, Murray was talking about hectares, but I think we'll need quite a few hectares if we were to do that, or mechanical drying. But once again, that all pushes the price up. Yeah, and Stephen mentioned before the carbon, where we were going with the carbon emission things. That's not there just now. So the DEC is more of a reference site at this stage. Hoping more people come on board with it, recognise and will pay that premium. Or the government decides that it really needs to go down that road again and, you know, push people that way a little bit.
And is it coal?
We're on coal just now. We burn Takatimi. We've done a combination of quite a few coals over the years. But, yeah.
It's great to hear that in the conversion to wood chip for this boiler, you're actually exceeding your capacity sort of expectations in terms of generation of steam and so on. I know it's something I've heard a number of times in the south of the region that, you know, people are concerned that you won't get the heat out of wood. So, you know, it's really good to have that sort of confirmation from a local project that is a possibility.
Oh, yeah, that was one of the first things when we put the new windswept spouts on. The guys that were tuning it, you know, were watching it go up, and it was going up and up and up, and said, "Oh, we need to peg this back a bit because we don't want to go over MCO." So,
could you tell me a little bit about the installation of the Southland Hospital? Someone mentioned that was dual fuel, but so
it's dual fuel capabilities. Currently, we're running just lignite at that installation just now. Once again, these are all future things. It's all around, unfortunately, cost at some stage. So, yeah.
When we get the opportunity to, as we have with the hospital here in Cable, to invest in new equipment, you know, we'll advise our customers, our partners, to give yourself some future proofing, put something in it, will give you some optionality going forward.
What size boiler is it, or what size boilers are it?
We've got 4 boilers in there, and they're all around 7 megawatt each, or thereabouts. So yeah, so they're all capable. 2 of them are a little bit older, so they're slightly low, but averaging 10 tonne an hour at full load. So during the winter, we're pretty much up there.
If you compare the calorific value of wood chips and coal, do you find the wood chip, you're looking at the boiler efficiency, is it more efficient using the wood or still using the coal?
Well, it depends on the coal. When we first kicked it off, we were on lignite. They were pretty much both the same. Now we've gone to a slightly higher. So the calorific value on the wood is slightly lower than the current coal we're doing, but it would depend on the moisture and things like that.
Just wondering if you got a higher efficiency out of the wood, you know, relative to calorific value than the coal, or?
Very similar, pretty much, yeah, from what we found from the steam figures.
that's to do with the boiler configuration. So that's some limitations of the boiler configuration.
Yeah.
To prove efficiency, you've basically got a boiler that can be designed for coal.
But there are some other efficiencies, as Tony mentioned, with the ash, with a lot less ash.
What happens with the ash, Tony? That was just carted out last time.
Well, it's currently we still, you know, it's still the easiest, the economical way for us, but it is backloaded back to the mine, so it's not just dumped into a landfill. So it is put back to where it originally came from, under consent and stuff like that. So.
A lot less ash, I too, yes.
If from the wood it is, yes, as I mentioned, cleaning the fires, we can go. We did push it one time. We went 4 days before the guys felt, oh, we better give it a bit of a clean. So 4 days at full firing rate, that's pretty good. You know, it's.
I also picked up from your talk that you're getting this high efficiency when you're blowing the fuel in by air, through the air.
Yeah, rather than the flickers.
Through an auger.
Yeah, there was.
So you get more.
Yeah, the air one, distributes a lot better. Under the old system, there was just sort of a flicker one that just flicked it on. But because of the clearances and that, we had a lot of jamming issues. This way, it's just blown straight in. The air is on a ramped up and down, so that you get your even spreads all across and everything like that.
So you're pre-drying your in-feed fuel?
No, it's just seasoned wood that Murray's.
Just seasoned.
Yep.
Now, further to that, it seems to me to be a sort of a hiccup having stored with wood for a year. There's another technology for part of the heat generated by a boiler to actually pre-dry, wet, or relatively wet chip. So you could deliver, if you see what I mean, relatively wet stuff. And the heat from the boiler actually converted to dry, which is what's fair thing.
Yeah, you're losing a lot of efficiencies by having to use the energy that you would be normally selling to somebody to dry the wood to get wood. So it doesn't really.
So it would make up for the inefficiency of having a stockpile on a big heat for 12 months, I presume.
Yeah, well, maybe the volume. We haven't sort of looked into that into huge depth. But Murray might be able to answer that one a bit better.
There are boilers that'll burn green fuel, so I mean that's fine. I mean this was a conversion to wood with low capital cost. So I mean as opposed to spending $10 million, so you could spend $10 million and have a boiler that would burn wet fuel. There are some of them that have gone in, so I mean, but yeah, that's the trade-off really. You get payback on that $10 million investment.
So you see low cost to upgrade, what are we talking?
Yeah, significantly low. Well, you know, it depends what you call low, I suppose. you know, if you call 100,000 or you know, or something like that, or thereabouts, or
We spend upwards of 100,000 putting feeders in.
Still pretty low, isn't it?
So how much chip do you store on site? How much wood do you have in your hopper?
Well, we're delivering every day, and that's probably one of the issues. You know, because we're cranking that boiler out and it's going flat out. So Murray delivers every day. We have a capacity. I think it's about I haven't actually measured it. In terms of coal, we're using the same bunkers. They would hold 50 tonne each side. So volume, I'm sure that 35 cubic metre, 40 cubic metres.
Probably at least 60 cubic metres on each side. Yeah, so you've got 120. You're going through 150 cubic metres a day if you're running flat out, probably more. Yeah. So
I'd say we'd probably pretty much 50% firing rates, you know, up to, you know, almost 100%. So yeah, we're pushing it through there. So Murray's in there every day, delivering wood to us. So yeah, that would, for the big picture, certainly you would have to look at all those things if you were going to you know, go more boilers or put a wood boiler in, you know, a dedicated one. Yeah, you'd have to look at all those issues.
On what basis do you pay for the wood? Is it weight at a moisture content, or is it by the truckload?
Gigajoules. So it's measured. So it's calculated from the moisture. Yeah. So we buy it, you know, pay by energy rather than weight or volume. So.
Or just or the wood that's going into this particular boiler?
Well, we buy it from Murray on an energy value.
Yeah.
Do you want to explain that, Murray, how that works?
well, there's just a formula that works out the tonnes based on the moisture content, and so if it's wetter, obviously you have more tonnes, but the energy value per tonne is less. So, yeah, so coal's sold by the gigajoule. We sell by gigajoule net rather than gigajoule gross, like sort of a little complication, but it means that there's an advantage. If our fuel is dry, we get a bit more advantage. Coal doesn't change very much in moisture content, it's pretty static, whereas wood can go anywhere between 10 and 60%, and so you really need to sell it on a gigajoule net basis.
Makes sense.
Yep.
Thanks for the discussion. Yeah, well done. Thank you, Tony. Thank you, Murray and Stephen. Really good stuff. We're really getting the brains sticking now as we start to apply it to the industry.